Below in this lecture we find out the radius of a circle. In the drawing we have a circle. Inside the circle we have chord TB is equals to 2 units in its length. Chord AC equals to the square root of 2 units in its length. This is angle DEB. That is equals to 45 degrees in its size. Again, our mission is to find out the radius of this circle. So, in the first step, we join points A and D together by straight line. By joining points A and D, we get the peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle. We define the size of this peripheral angle DAB is x over 2. So peripheral angle DAB equals to x over 2 degrees in its size, and this peripheral angle DAB subtend on chord DB. Again, peripheral angle DAB subtend on chord DB. We define the center of this circle. This point is point O. We join points O and D together by straight line. And we join points O and B together by straight line. By doing this construction, we get the center angle DOB. This is center angle DOB. Center angle DOB. Again, this is center angle DOB. And center angle DOB subtend on chord DB. Again, center angle DOB subtend on chord DB, exactly like peripheral angle DAB. That is also subtend on the same chord called DB. Now we can implement here rule 13. Repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have this is peripheral angle ACB, and the side of this peripheral angle ACB is theta, and this peripheral angle ACB subtend on chord AB. Again, peripheral angle ACB subtend on chord AB. Likewise, we have also here central angle AOB. This is central angle AOB. It's also subtend on the same chord called AB. And according to this rule 13, the size of peripheral angle, the size of central angle AOB must be twice as large as the size of this peripheral angle ACB. Why? Because both of them, they subtend on the same chord called AB. Therefore, the size of the central angle must be twice as large as the size of the peripheral angle. But the size of the peripheral angle is theta, and therefore the size of the central angle AOB that subtend on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have peripheral angle BAD. This is peripheral angle BAD. The size of this peripheral angle BAD is x over 2, and peripheral angle BAD subtend on chord BD. And we also have here center angle DOB. This is center angle DOB that is subtend on the same chord called BD. And therefore the size of the center angle BOD must be twice as large as the size of the peripheral angle BAD. Why? Because both of them subtend on the same chord called BD. The size of peripheral angle BAD is x over 2. Therefore, the size of the center angle BOD must be equal to x. Why? Because both of them subtend on the same chord called BD. According to rule 13, the size of the center angle BOD must be twice as large as the size of this peripheral angle BAD. The size of this peripheral angle BAD is x over 2, therefore the size of the center angle BOD, it subtends on the same chord called BD, must be equal to x. Okay? So we will define the size of peripheral angle ADC. The size of this peripheral angle ADC is y over 2. So peripheral angle ADC subtend on chord AC. Again, peripheral angle ADC. This is peripheral angle ADC that subtend on chord AC. Okay, in the next step, we join points O and A together by a straight line. Likewise, we join points O and C together by a straight line. When doing this construction, we consider center angle AOC. So this is center angle AOC that is created with those two constructions. Center angle AOC subtend on chord AC exactly like peripheral angle ADC that subtend on the same chord called AC. So both those two angles they subtend on the same chord called AC. And therefore, according to rule 13, the size of the center angle AOC must be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, therefore the size of this center angle AOC that subtend on the same chord called AC must be equal to y. According to rule 13. Okay. In the next step, I'll copy triangle AED. This is triangle AED in a new page, and we'll implement rule 4 in this triangle AED. So actually, this is triangle AED to the comment from the original drawing. Those two angles and this angle those three angles are defined as interior angles of this triangle, triangle AED. Why? Because of the fact that those three angles are all located inside the triangle AED. Therefore, those three angles are all defined as interior angles of this triangle, triangle AED. While this angle, angle BED, this is angle BED, that is equals to 45 degrees inside. This angle BED is defined as an exterior angle. Why? Because it is located outside triangle BED. This is the exterior angle in relation to triangle AED. Now we can implement rule 4 in our drawing. So I'll click quickly on rule 4. According to rule 4, the exterior angle of a triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing you have a triangle, and those three angles A, B, and C, they are all defined as interior angles of this triangle. Why? Because of the fact that they are located inside the triangle, and therefore they are defined as interior angles. While this is angle E, that is defined as an exterior angle, why? Because it is located outside the triangle. According to this rule 4, the size of this angle E equals to the sum of the two interior angles that are not adjacent to it. This is angle C. Angle C is definitely adjacent to angle E. And therefore the two other interior angles that are not adjacent to angle E are A and B. And the sum of those two angles are A plus B. So the size of the exterior angle E equals to A plus B. A plus B is the sum of the two interior angles that are not adjacent to this angle E. So in conclusion, we found out the size of this interior angle E equals to A plus B. A plus B is the sum of the two interior angles that are not adjacent to angle E. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have the exterior angle DEB. The exterior angle DEB, the size of exterior angle DEB is 45 degrees. According to rule 4, the size of the exterior angle DEB, that is actually 45 degrees, it is equals to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to this angle, and therefore the two other interior angles that are not adjacent to it are x over 2 and y over 2. So the size of angle DEB, according to rule 4, equals to x over 2 plus y over 2. So I write it down. According to rule 4, the size of the exterior angle DEB, this is angle DEB, is equals to the sum of the two interior angles that are not adjacent to it. This angle adjacent to this angle, and the two other interior angles that are not adjacent to it is x over 2 and y over 2. So according to rule 4, the sum of those two interior angles that are not adjacent to it is x over 2 plus y over 2. And the size of this exterior angle DEB is equals to the sum of the two interior angles that are not adjacent to it. That is to say, it is equals to x over 2 plus y over 2. But it is given us the equation that the size of angle DEB is 45 degrees. Therefore, we can substitute DEB by 45 degrees. We do it now, and we get that the size of angle DEB, that is 45 degrees, it is equals to the sum of the two internal angles that are not adjacent to it. That's actually x over 2 plus y over 2. Here we multiply this equation by 2 and finally get that 45 times 2 is 90 degrees. So 90 degrees equals to x plus y. Here we subtract x from this equation and finally get that y equals to 90 degrees minus x. So this will be equation 1. According to equation 1, we should found out that y equals to 90 degrees minus x. Okay. Here, point O is the center of the circle, point B is the point on the circle itself, therefore line segment OB is the radius of this circle. We define the radius of this circle as R. R is the radius that we are looking for in this question. So OB equals to R. Likewise, OD is also equals to R. CO is also equals to R. And finally, AO is also equals to R. So all the radii of this circle is equals to R according to our definition. In the next step, I'll copy triangle ODB, this triangle ODB in a new page, and we will implement the law of cosines in this triangle, triangle ODB. Side OB equals to R, it is the radius of the circle. Side OD also equals to R. And side DB equals to 2 units in its length according to what is given as a question. So actually, this is triangle ODB that I got it from the regular drawing. In the next step, we'll implement the law of cosines in this triangle, triangle ODB. But first of all, I will present to you the law of cosines quickly. First of all, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. In triangle ABC, the length of side AB is A. Side AC equals to B units in its length, and side BC equals to C units in its length. And angle BAC, this angle BAC equals to theta degrees in its size. In this triangle, triangle ABC, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So this law, this is the law of cosines, is true in any triangle. Therefore, we can implement the law of cosines in this triangle, triangle ODB. So according to the law of cosines, the law of cosines, in this triangle ODB, we get that cosine x equals to OD squared, that is R squared, plus OB squared, that is also R squared, minus DB squared. DB is 2, therefore DB squared is 2 squared, that is 4, divided by 2 times OD, that is R, times OB, that is also R. So in conclusion, we found out that according to equation 1, cosine x equals to R squared plus R squared, that is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 4 divided by 2 times R times R. 2 times R times R is 2R squared. So here 2R squared over 2R squared is 1, and we have also here minus 4 over 2R squared. So this expression cosine x in total equals to 1 minus here we divide both the numerator and the denominator of this expression by 2. So here minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in conclusion, we should find out that according to equation 1, cosine x equals to 1 minus 2 over R squared. Repeat again, according to equation 1, we have found out that cosine x equals to 1 minus 2 over R squared. Okay, so in the next step, I'll copy triangle AOC, this triangle AOC in a new page, and we will implement the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. Side AC equals to the square root of 2 units in its length. Both CO and AO, they are the area of the circle, that is equals to R. And this is angle Y. Angle AOC equals to Y. So according to the law of cosines, cosine Y equals to R squared plus R squared minus square root of 2 squared, that is 2, so it is minus 2, divided by R squared divided by 2 times R squared divided by 2 times R times R. And again, according to the law of cosines, in triangle AOC, cosine Y equals to R squared plus R squared minus 2 over 2 times R times R. So according to this equation 2, cosine Y equals to R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 2 divided by 2 times R is 2R squared. 2R squared over 2R squared is 1. And we have also here minus 2 over 2R squared. So according to equation 2, we have found out that cosine y equals to 1 minus 2 over 2 all square. Repeat again, we should find out that according to equation 2, cosine y equals to 1 minus 2 over 2 all square. Here we will divide both the numerator and the denominator of this expression by 2, and you get that cosine y equals to 1, and we have minus 2 over 2 is minus 1, and 2 all square over 2 is all square. So according to equation 2, we actually found out that cosine y equals to 1 minus 1 over all square. But we've already found out in the beginning of the lecture that y equals to 90 degrees minus x. So I write it down. We already found out that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation 2, by 90 degrees minus x. We'll do it now, and you get that cosine y. So it is cosine, and y is 90 degrees minus x. And it is equals to 1 minus 1 over r square. And according to equation 2, we found out that cosine 90 degrees minus x equals to 1 minus 1 over r square. We have the trigonometric identity that states that sinus x is equals to cosine 90 degrees minus x. According to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2, by sinus x. We'll do it now, and you get that according to this equation 2, again, according to this trigonometric identity, cosine 90 degrees minus x is sinus x. So instead of cosine 90 degrees minus x by sinus x, so sinus x, according to equation 2, equals to 1 minus 1 over r square. Repeat again, according to equation 2, we actually found out that sinus x equals to 1 minus 1 over r square. This is according to equation 2, and according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r square. So we have here two expressions for sinus x and for cosine x. But we also have the trigonometric identity that states that sinus square x plus cosine square x equals to 1. We already found out that according to equation 2, sinus x equals to 1 minus 1 over r square, when according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So now we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and we can substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We will do it now. So this will be equation 3. So equation 3. In this trigonometric identity we have sinus square x. And according to equation 2, sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared plus cosine x squared plus cosine square x. Cosine x, according to equation 1, is 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and sinus square x plus cosine square x equals to 1. So if we found out that according to equation 3, 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. Here we will define t as 1 over r squared. So now we can substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to equation 3, we have here 1 and minus 1 over r squared. And 1 over r squared, according to our definition, is t. So we substitute 1 over r squared in this equation 3 by t. So this expression in total will be equal to 1 minus t squared plus 1 minus 2 times 1. It is 2 times 1. So it is 1 minus 2 times, and 1 over r squared is t. So we substitute 1 over r squared by t squared equals to 1. So if we found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. We open the brackets on this side of this equation 3, and we get that according to this equation 3, we have here 1 minus t squared, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t, that is minus 4t, equals to 1. So if we found out that according to equation 3, 1 plus t squared minus 2t plus 1 plus 4t squared minus 4t equals to 1. So here we have 1 on both sides of the equation, so 1 will get cancelled. So after we cancelled 1, this side of the equation we have t squared plus 4t squared is 5t squared. And we have minus 2t minus 4t minus 6t plus 1 equals to 0. So we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t. The coefficient a equals to 5 units. The coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and we find out the value of the values of t, because x equals to t. So we do it now, and we get that again x equals to t, therefore we substitute x by t. So t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6. Plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a. A is 5, so minus 4 times 5 is minus 20. Times c. C is 1, therefore minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, therefore 2a is 2 times 5, that is 10. So actually found out that t equals to 6 plus minus, inside the root we have 36 minus 20, 36 minus 20 is 16, so inside the root we left only with 16 divided by 10. So t equals to 6 plus minus square root of 16 is 4 divided by 10. So actually found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution, t equals to 1. T equals to 1. But according to our definition, t equals to 1 over r squared. Therefore we substitute t by 1 over r squared. So 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally get that r squared equals to 1. Here we take a root out of this equation, and you get that the radius r that we are looking for is equals to the square root of 1, that is 1. So according to the first solution for t, the radius r of this circle is equals to 1 unit in its length. But it is impossible that the radius r of this circle is equals to 1. Why? Because we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And here we have chord DB is equals to 2. We know that chord DB equals to 2. And chord DB is definitely not the diameter of the circle. Again, chord DB is definitely not the diameter of the circle. Okay? So the diameter of this circle is 2r, so the diameter of 2r must be greater than chord dB, that is not the diameter. Must be greater than chord dB, that is not the diameter. Because the diameter of any circle is the longest chord in the circle. Therefore, the diameter of 2r must be greater than dB, that is not the diameter. But dB equals to 2 according to what is given in the question. And from this inequality, 2r greater than dB equals to 2, we will derive that 2r is greater than 2. Here we divide this inequality by 2, and finally we get that the radius r of the circle must be greater than 2 over 2 is 1. So the radius r of this circle must be greater than 1. If the radius r must be greater than 1, the radius r cannot be equal to 1. So we cancel this solution. This solution is a correct solution. So we left only with the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5. But according to our definition, t also equals to 1 over r squared. So we can substitute t by 1 over r squared in this equation. So 1 over r squared equals to 1/5. Here we cross multiply this equation and get that r squared equals to 5. Here we take a root out of this equation and finally get that the radius r that we are looking for is equals to the square root of 5 units in itself. Or in terms of numbers, it is equals to 2.236 units in its length. So repeat again, we actually found out that the radius r of this circle is equals to either square root of 5 units, or in terms of numbers, it is equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle, and inside the circle we have chord dB that is equals to 2 units in itself. This is chord AC that is equals to the square root of 2 units in itself, and this is angle DEB that is equals to 45 degrees in its size. And our mission is to find out the radius of this circle. So in the first step, we joined points A and D together by a straight line. By joining points A and D, we created peripheral angle BAD. We define the size of this peripheral angle BAD is x over 2. So peripheral angle BAD equals to x over 2 degrees in size. And this peripheral angle BAD is subtended on chord DB. Again, peripheral angle BAD is subtended on chord DB. We define the center of this circle, this point as point O. Then we join points O and B together by a straight line. We join also points O and D together by a straight line. By doing this construction, we get the center angle BOD. This is center angle BOD. Now we know that center angle BOD is also subtended on chord DB. Again, center angle BOD is also subtended on chord DB. That is exactly like peripheral angle BAD. That is also subtended on the same chord called DB. And therefore we can implement here rule 13. So quickly on rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have, this is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on arc AB. Again, peripheral angle ACB is subtended on arc A, on the chord AB. Likewise, we have the central angle AOB. This is the central angle AOB that is subtended on the same chord called AB. And therefore, according to this rule 13, because of the fact that those two angles are both subtended on the same chord called AB, the size of this central angle AOB must be twice as large as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, therefore the size of this central angle AOB that is subtended on the same chord called AB must be equal to 2 theta. So we can actually implement this rule 13 in our drawing. Why? Because in our drawing we have peripheral angle DAB is subtended on arc BD, and this equals to x over 2 degrees in its size, and therefore the central angle DOB that is subtended on the same chord called DB must be twice as large as this peripheral angle DAB. This peripheral angle DAB is equal to x over 2, therefore the central angle DOB that is subtended on the same chord called DB must be equal to x. Okay, according to rule 13, of course. In the next step, we defined the size of this peripheral angle CDA as y over 2. Again, this peripheral angle CDA is equal to 1 over 2 degrees in its size. Then we join points O and C together by a straight line. We join points O and C together by a straight line. We join points O and A together by a straight line. By doing this construction, we created central angle AOC. This is central angle AOC. It's subtended on chord AC, exactly like peripheral angle ADC. This is also subtended on the same chord called AC. And therefore, according to rule 13, the size of this peripheral angle AOC is subtended on the same arc as this peripheral angle ADC must be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of the central angle AOC that is subtended on the same chord called AC must be equal to y. Okay, according to rule 13, of course. In the next step, I copied triangle ADE in a new page, and we implemented rule 4 in this triangle ADE. So actually, this is triangle ADE that I got from the original drawing. We know that this is angle DEB is equals to 45 degrees inside, and this angle equals to x over 2, and this angle equals to y over 2. So those three angles, x over 2, y over 2, and this angle, they are all defined as interior angles because they are located inside the triangle DEB, and this is angle DEB. This is an exterior angle because it is located outside triangle DEB, triangle ADE. It is located outside triangle ADE. Therefore, this angle DEB is defined as an exterior angle in relation to triangle ADE. Again, DEB is an exterior angle because it is located outside triangle ADE. So, according to rule 4, the size of the exterior angle DEB must be equal to the sum of the two internal angles that are not adjacent to it. This internal angle is adjacent to this angle, and the two other angles that are not adjacent to it is this angle x over 2 and y over 2. And the sum of those two angles is x over 2 plus y over 2, and according to rule 4, x over 2 plus y over 2 must be equal to the size of this external angle DEB. Okay, again, according to rule 4, the size of angle DEB equals to x over 2 plus y over 2. But angle DEB equals to 45 degrees in its size, according to what is given us in the question. Therefore, we can substitute angle DEB by 45 degrees. So if we found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2, and finally found out that x plus y equals to 45 degrees times 2, that is 90 degrees. Here we subtracted x from this equation, and finally found out that y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. In the next step, we copied triangle BOD, this triangle BOD, in the new page, and we implemented the law of cosines in this triangle BOD. So actually, this is triangle BOD that I copied from the original drawing. This angle DOB equals to x, side DO equals to side BO, they are both the area of the circle, and therefore they are equal to R according to our definition. It is given as the question that side DB equals to 2 units in itself. So I repeat quickly on the law of cosines, and then we'll implement the law of cosines in this triangle DOB. According to the law of cosines, first of all, the law of cosines is true in any triangle. So this triangle ABC could be any triangle. We know that the size of side AB is A, side AC equals to B units in itself, and side BC equals to C units in itself. This is angle BAC. The side of this angle BAC is theta. So according to the law of cosines, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement the law of cosines in triangle DOB. Triangle DOB, according to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4, so cosine x equals to r squared plus r squared minus 4 over 2 times r times r. So cosine x equals to r squared plus r squared minus 4 over 2 times r. R squared plus r squared is 2r squared, so in total, in the numerator of this expression, we have 2r squared minus 4, and 2 times r is 2r squared. So in conclusion, we should found out that cosine x, according to this equation, equation 1, cosine x equals to 2r squared minus 4 over 2r squared. 2r squared over 2r squared is 1. So in total, this expression equals to 1 minus 4 times 2r squared. So it is 1, and we have minus 4 over 2r squared. So here we divided both the numerator and the denominator of this expression by 2. And we actually found out that minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we actually found out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Repeat again. According to equation 1, we actually found out that cosine x equals to 1 minus 2 over r squared. In the next step, I copied triangle AOC in the new page, and we implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. This is angle AOC, that is y. Side AO equals side CO. They are both the radii of the circle. That is equals to r according to our definition. and side AC equals to the square root of 2 units in itself, according to what is given in the question. So in this triangle AOC, according to the law of cosines, cosine y equals to r squared plus r squared minus square root of 2 squared, that is 2, divided by 2 times r times r. So according to equation 2, actually found out that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y according to this equation, equation 2, equals to r squared plus r squared is 2r squared minus 2, and 2 times r is 2r squared. So here we have, according to this equation 2, cosine y equals to 2r squared over 2r squared is 1, minus 2 over 2r squared. So here, again, actually found out that according to equation 2, cosine y equals to 1 minus 2 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2, and found out actually that in total cosine y equals to 1, and minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in total actually found out that cosine y equals to 1 minus 1 over r squared. But we already found out that y equals to 90 degrees minus x. Here, we found out that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation 2 by 90 degrees minus x. We did it, and found out actually that cosine y, and y is 90 degrees minus x, equals to 1 minus 1 over r squared. But we have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. Therefore, we can substitute cosine 90 degrees minus x by sinus x according to this trigonometric identity. We did it and found out actually again cosine 90 degrees minus x is sinus x according to this trigonometric identity. So sinus x equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have here two expressions for sinus x and cosine x. Now, we implemented, actually used the trigonometric identity, that states that sinus square x plus cosine square x equals to 1. And we already found out that sinus x according to equation 2 equals to 1 minus 1 over r squared, and cosine x according to equation 1 equals to 1 minus 2 over r squared. So now we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and we can substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We did it, and we actually found out that sinus x according to equation 2 is 1 minus 1 over r squared. Therefore sinus square x will be equal to 1 minus 1 over r squared plus cosine square x. Cosine x according to equation 1 is 1 minus 2 over 2 r. Again, cosine x equals to 1 minus 2 times 1 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and it is equal to 1. So here we defined 1 over r squared is t equals to 1 over r squared according to our definition. Therefore we can substitute 1 over r squared in this equation 3 by t. We did it and found out actually that according to this equation 3, 1 minus 1 over r squared, 1 over r squared is t squared, plus 1 minus 2 times 1 over r squared. So it is 1 minus 2 times, and 1 over r squared is t squared equals to 1. So after we substitute 1 over r squared by t, we got that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets in this side of this equation 3 and finally found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and we have also here 1 plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared plus 2t squared. 2t squared is equals to 4t squared, minus 2 times 2t is minus 4t equals to 1. So after we open the brackets on this side of the equation 3, in total found out actually that 1 plus t squared minus 2t plus 1 plus 4t squared minus 4t equals to 1. So here we have 1 squared on both sides of this equation 3, so 1 will get cancelled. After we cancelled 1, in this side of the equation we left with t squared plus 4t squared is 5t squared, minus 2t minus 4t is minus 6t, plus 1 equals to 0. So actually found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x. In this way we find out the value of t, because x equals to t. So x equals to t, so we substitute x by t, and it is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. So it is minus 4 times a, and a is 5, so minus 4 times 5 is minus 20, times c. c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20, divided by 2a. a is 5, so 2a is 2 times 5, that is 10. So in conclusion, we found out that t equals to 6 plus minus square root of 36 minus 20 over 10. 36 minus 20 is 16, so inside the root we left only with 16. And finally found out actually that t equals to 6 plus minus square root of 16 over 10. Square root of 16 is 4. So actually found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t, t equals to 1. But according to our definition, t equals to 1 over r squared, so we can substitute t by 1 over r squared. We did it, and we found out that t, that is 1 over r squared, equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took out of this equation, and finally found out that the radius that we are looking for, r equals to the square root of 1, that is 1. So according to the first solution for t, the radius r of this circle is equals to 1 unit in its length. But it is impossible that the radius r of this circle equals to 1. Why? Because of the fact that we know that chord dB equals to 2 units, but chord dB is definitely not the diameter of this circle. Again, chord dB is not the diameter of the circle, and we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And dB that is not the diameter of the circle is equal to 2 units in its length. So the diameter 2r of our circle must be greater than db that is not the diameter. Because the diameter of a circle is the longest chord in the circle. So the diameter 2r must be greater than db that is 2. So if we found out that 2r is greater than db, is equals to 2. So according to this inequality, we actually found out that 2r is greater than 2. We divided this inequality by 2, and we actually found out that 2r over 2 is r, and 2 over 2 is 1. So in conclusion, we actually found out that the radius r of the circle must be greater than 1. We actually found out that the radius r of this circle must be greater than 1. If the radius r of this circle must be greater than 1, then the radius r cannot be equal to 1. Therefore, cancel this solution, and we're left only with the second solution that is possible for t. The second solution that is possible for t is that t equals to 6 times 4 over 10. 6 times 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5. But according to our definition, t equals to 1 over r square. So we saw that we substitute t by 1 over r square, and according to this equation, t that is 1 over r square equals to 1/5. So 1 over r square equals to 1/5. We cross multiply this equation, and finally found out that r square equals to 5. Here we took out of this equation, and finally found out that the radius r of this circle, the radius that we're looking for, the radius r of this circle equals to either the square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units in its length. Again, the radius r of this circle, it is equals to either the square root of 5 units in its length, or in terms of numbers, the radius r equals to 2.236 units in its length. Okay, thank you very much.